Hi everyone. I hope all of you are doing well. In the last video, we discussed about the concept of non-contiguous memory allocation scheme. In non-contiguous memory allocation, we have two techniques. One is paging and the second one is segmentation. In the last video, we discussed the paging scheme of allocation in detail. However, in this video, I'm planning to complete the concept of segmentation. So basically, segment is a logical entity of the program such as function, data, main program, etc. Segmentation, it always supports the user view of memory. Segment, it represents the logical entity of the program. Here in case of segmentation, the logical program, that is the process or program, it is divided into the blocks which are known as segments. But remember, these segments will be representing the logical entities of the program. Here we have an example. We have a process, say Q, and this process may consist of the main program, some functions like search, update, and also may include some database, and also may consist of stack. These different logical entities, they can be treated as the different segments. For each of the segment, the operating system will maintain some information as shown in the segment table. It maintains information such as name of the segment, size of the segment, and address of the segment. For each of the program, such information is maintained by the operating system. As we know, the CPU always it will be generating logical address. This logical address, it consists of two fields, segment number and offset. The logical address generated by CPU is divided into two parts. They are called as segment number and offset number. The segment number indicates the number of the segment, that is first segment, second segment. That segment number is indicated by using this first field, and the offset indicates the particular location within that particular segment. Say for example, if segment number is 2 and offset is 20, that indicates that 20th byte of segment 2. So segment number indicates which particular segment, offset indicates the particular location within the segment. Then the operating system employs segment table to convert logical address into physical address. So to convert logical address into physical address, the operating system employs the data structure called segment table. This segment table consists of two fields. One is base and the second field we call it as limit. So base field, it holds the starting address of the segment where the segment is stored in physical memory. The base contains starting physical address where that segment is stored in the memory. On the other hand, the limit contains the length of the segment. Students, please try to understand. The base field, which is used in the segment table, it holds base address of the segment in physical memory. And limit, it specifies length of the segment. What is the size of that segment? That we indicate by using limit. Then apart from this, for segmentation, we use two interesting registers, STBR, that is segment table base register, and segment table length register, that is STLR. These two registers are used for implementing segmentation. The segment table base register always it points to the location of segment table in the memory. Even that segment table is also stored in physical memory. It is also stored in main memory of the program, right? The segment table register always it points or it holds the address of segment table. Then segment table length register, it indicates the total number of segments used within the program. Say for example, if your program consists of 4 segments, then that number 4 is stored within segment table length register. So in generally we can say that while accessing any of the memory location, that segment number yes will be legal only if it is less than length of only if it is less than the value stored within STLR. When a logical address is generated, we are going to check whether the segment number is less than the number of segments which are specified within that particular program. So here students can find out how the segmentation concept works out. If you look at here, we have the CPU, we have physical memory, and this table we call it as segment table. As we discussed, basically CPU, it generates logical address. The logical address will have 2 fields as we discussed. They are segment number and offset. This segment number is used to obtain starting address of that segment in the physical memory by using segment table. We first consider this segment number. We use this segment number to obtain the starting address of that particular segment in the memory location with the help of segment table. Then D, as we discussed, it is offset. We are going to check whether this D is less than the limit value of the segment. As we discussed, limit, it contains the size of the segment. If the offset value specified in the segment address, if the offset value specified in the logical address, if it is less than the limit of that particular segment, then simply we add this offset value D with the base address of the segment. Say for example, we assume that segment number is 2 and D is equal to 54. So by using the segment table, we are going to find out the starting address of the segment number 2. Assume that the segment number 2 begins with address 1000. We check this D value, that is 54. Is it less than the size of the segment? Is it less than the value limit? If it is so, we add this 54, that is D value, with base address of this segment number. A segment number in the example we discussed is 2000. That 2000 plus 54, we get 2054, right? That 2054 is nothing but we can say the physical address where we can find out 54th byte of segment 2 in the physical memory. This is how the logical address is converted into physical address in case of segmentation. And suppose if this value of D, that is offset, if it is exceeding the limit value of the segment, in that case, an interrupt is generated indicating segment violation. If D value exceeds the limit, in that case, an interrupt is generated indicating that the address generated is wrong. So this is the concept of segmentation. Okay, students, here we have one more slide, that is the comparison between contiguous and non-contiguous memory allocation schemes. Till now, we have discussed the concept of contiguous memory allocation and non-contiguous memory allocation. We have seen that in contiguous memory allocation scheme, we have 3 algorithms. They are first fit, best fit, and worst fit. And in case of non-contiguous memory allocation, we have 2 methods. They are paging and segmentation. Now, after studying all these concepts, here we are going to compare both the allocation techniques, that is contiguous and non-contiguous allocation. Here, first we have listed out the feature. With respect to each of the feature, we are going to compare contiguous and non-contiguous allocation. First, we have overhead. So in case of contiguous allocation, no overhead during execution of the program, because we know that in case of contiguous allocation scheme, a contiguous block of memory is allocated for the program. But in case of non-contiguous allocation scheme, there will be some overhead, because in non-contiguous memory allocation scheme, we are going to distribute the different components of the program into different parts of the physical memory. That's why we need to convert logical address into physical address in case of non-contiguous allocation. That's why for this address translation, there will be some execution overhead. Remember, in case of contiguous allocation, there will be no overhead during execution of the program. But however, in case of non-contiguous allocation, as address translation is required, there will be some overhead. Then with respect to allocation, as we have seen in case of contiguous allocation, it allocates a single area of memory. The contiguous allocation scheme, always it allocates a single contiguous block of memory to the program. In the non-contiguous allocation scheme, it allocates the several memory blocks for each component of the process. As we discussed, the idea is that the program is divided into multiple parts or multiple components. Each of these components, they are stored in different part of the physical memory. With respect to reuse of memory, that is memory wastage or fragmentation, if you consider the contiguous memory allocation scheme, always it suffers from internal fragmentation. There exists internal fragmentation in partitioned allocation, because we know that we are going to allocate a single contiguous block, and if the program will not utilize the complete block of memory, some space of that block is going to remain unused. So it leads to internal fragmentation. External fragmentation exists in case of first fit, best fit, and next fit allocation. When you consider non-contiguous allocation scheme, in the paging, we won't get external fragmentation. There is no question of external fragmentation in the paging scheme. But however, in the segmentation scheme, there exists external fragmentation, but no internal fragmentation. Remember students, in paging, we get no external fragmentation, but there is a possibility of internal fragmentation. I'll give an example. Assume that you have used the size of the page as 1 kilobyte. Suppose if your program is 2.5 kilobytes, you have to allocate 3 pages. First page 1 kilobyte, second page 1 kilobyte, and third page size will be again 1 kilobyte only. But in the third page, only half kilobyte, that is 0.5 kilobyte is stored, and remaining 0.5 kilobyte of that page remain unused. That leads to internal fragmentation. In segmentation, we get external fragmentation, but there will be no internal fragmentation. And with respect to swapping, so swapping is one of the important technique used while storing the programs. We have discussed in case of time sharing systems. So in case of contiguous memory allocation, unless the computer system provides a relocation register, swapped in process must be stored in its original location. The meaning is that in case if you are employing swapping in the operating system, and if the memory is allocated with contiguous allocation scheme, there the process need to be stored in its original location. The swapped in process need to be stored in its original location in case if relocation register is not provided. Okay. And in case if you are using non-contiguous memory allocation scheme, there is no restriction that the swapped process need to be stored in its original location. In that case, the swapped in process can be stored in any of the memory location. In case of non-contiguous allocation, the swapped in process can be stored in any of the memory location. But in contiguous memory allocation scheme, the swapped in process need to be stored in its original location in case if we won't have relocation register. Students, this is the comparison between contiguous and non-contiguous memory allocation scheme. Remember, in contiguous allocation, there is no execution overhead, but in case of non-contiguous allocation scheme, as address needs to be translated, as address translation is required, there will be some overhead. And the contiguous allocation scheme always it allocates contiguous block of memory space to the program. But in non-contiguous memory allocation scheme, the program is divided into multiple parts, and these parts they can be stored in any portion of the memory non-contiguously. And the contiguous allocation scheme, it suffers from internal fragmentation. However, non-contiguous allocation scheme, if you consider, paging it suffers from internal fragmentation, but there will be no external fragmentation in paging. But in the segmentation, external fragmentation exists, but no internal fragmentation. With respect to swapping, if you consider, in contiguous allocation scheme, the swapped in process need to be stored in its original location. When the process is swapped in, that has to be stored in its original location in case if you don't have relocation register. But in the non-contiguous allocation space, the swapped in process can be stored in any part of the physical memory. When the process is swapped in, it can be stored anywhere in the memory in case of non-contiguous memory allocation scheme. Students, this is all about the segmentation, paging, and the comparison between non-contiguous and contiguous memory allocation scheme. Thank you, students. Thank you very much.